Let's solve the homework. For the problem number 1 here, if you thought about what is common, for example, from data perspective, the color, for example, all of them might have a color. So this is like a common attribute. In terms of methods, it seems like we have to draw, for example, all of them or compute the area of them. However, computing area, for example, is a different behavior from a triangle to rectangle to a circle. So we have like a common functionalities, but actually with different behavior. Meanwhile, there are some special things for every one of them. Triangle has only 3 sides, for example. Rectangle has 4. Circle doesn't have sides. It has something, it has a center and has a radius. So it seems like there are common things and special things. Soon we will study inheritance. Inheritance is all about grouping the common things together and differentiating the special things in different organization of the code. The target of the exercise is just like pushing you to be more motivated when we come to study inheritance. In the what versus how, back to the first problem, the task is summing the numbers from 1 to n. This is the task itself, but we can do that from different ways that you already know at the moment. For example, we can sum the numbers from 1 to n. This is very easy to code, but slow, especially for number like 10 to the power 10. On the other side, a formula like n times n plus 1. This is very efficient, single line of code, but you might take some time to think about it. This is easy to come to your mind. This takes some time to think about it. And as I said in the video, in many tasks can be handled really in different ways. Sometimes one of the tasks is really clearly written, some aren't. Sometimes your approach is very fast, like here, or slow, like that guy. Sometimes the solution is very memory hungry. Sometimes it is reasonable. Sometimes we have a solution that takes a lot of memory but very fast, or a solution that is reasonable in memory but very slow, and so on. These are all important concerns. For example, if the task is like heavily computations, your mobile probably will become very hot, which will not be a good idea for you. Some of the say mobile application would download a lot of data from your data package, which might not be a good idea for you, and so on. Back to the second task here, thinking about the system in terms of what and how. Let's say you are using something like a Facebook Messenger. Do you really care how the chat is happening behind the scene? How does Facebook scale up to 1 billion users or more? You don't care. You care how to write a message, how to send some emotion, and so on. In the same way, your TV or your car, most of us drive cars, but we don't know really what's happening inside it. This is the difference between what and how. And this is an important concept in software engineering. When we deal with customers, we mainly focus on telling them about the what, not the how. Thinking here about the effect of that on software engineering. Let's say we are developing this application for Android and iOS and the iPad. One of the principles is the dry principle. I think we highlighted it before, to avoid duplicating the code, to do not repeat yourself. In terms of the what and how, as we learned, filling a color is what, how to fill it is another task. Some of the functionality, let's say loading an image from a storage. Let's say you have a mobile application that have to load an image. Loading the image is a task, is a what. We would like to give an image name or path and load it. How to load it might depend on the system, for example, the iOS, the iPad, and so on. Whatever you think is common in terms of the implementation, in terms of the how itself, you should think about putting it somewhere as a common for everyone to use. And whatever is different, we should think how to split it in a different way so that we can provide different implementation or so. This is very vague, very high level. Later when we learn about inheritance, composition, and abstraction, we'll understand more about that. Again, the target of the question is just motivating you for the next sections. In the third task, we have the date time question, and the guy implemented all of them here together. One of the issues in this code is it is responsible for the details of 2 things: the date and all of its time, all its complication, and time and all of its complication. A better idea is to focus on a specific functionality per class. This is what we call single responsibility. Part of software engineer principles is the single responsibility principle, one of the greatest principles that we should keep applying in our work. The target of that is to keep tasks and functionalities focusing on something that is very, very specific. This is how we make the code easy to read, make tasks easy to distribute, make the development and the maintenance very easy. So here is how we can apply that here. I am going to make the date class a separate class that takes only 3 parameters here. So this is all the responsibility of that guy, the date issue. And another class for the time issue, involving all of the functionality of the time issue. And finally, a third target class, which is taking our 6 parameters, but is composed of or consisting of or has 2 objects, one from date and one of time, and doing some functionality that we really need to have on both of them together, like let's say printing, for example. So the date is printed in a string, the time is printed in a string, and then maybe we concatenate them together. This is how we split the responsibility of this big task to 3 different things. I would like you from now on to try to apply the single responsibility design pattern, the dry principle, and so on. By the way, this is code composition. When an object consists of other objects, this is code composition. Another example, like when you say a car is composed of an engine. This is an example of a composition. Remember, the employee class has an object from another class named full name, which has first, middle, and last name. This is all code composition. We'll learn more about composition during the course. The last 2 verbal statements about the debates. Debates are very common in companies. Be open for different views. There are many ways to solve every problem, and every problem has a lot of pros and cons. Try to be a logical person. Try to have logical reasons. Please try to work on your thinking skills. This is something that you find missing in industry. The people don't have good mentalities when it comes to thinking and logical thinking, critical thinking, and so on. And try to put some time to understand your colleagues' choices and reasons. Many of the guys in the market just would like to force their choices. They have bias and just would like to force it. And a lot of things are really vague. And many of things we really aren't sure what's really going to happen in the future. We, most of the time, especially with hard tasks, we don't know what's going to happen. We're just trying to do our best. It's much better to listen to others. And from my personal experience, in the first 5 years of your life at least, you will be wrong most of the time. So being ready to listen will be very critical. And try to have different weights. The minor design concerns like a small class isn't like system design. A system design refers to the complete system. We will learn more about that. Like I think about a system for the educational management system, a system for the email system. This is something very big. Design choices here are much more critical. Most of the time, if there are some experienced people around you, they probably met similar problems. Go ahead, talk with them. And here is one of the very golden rules that I learned from one of the guys. Put a time limit for discussions and make a vote. Like sometimes guys might keep debating for hours. This is a big waste of time. Try to have like a threshold. We're going to discuss this matter for the next hour. And after that, maybe make a vote and maybe utilize some experienced guy. If you found yourself have a very lengthy discussion, something is wrong. The last task here is about that guy, fresh guy who is like trying to be smart, preparing more features for the customer to be happy. One of the principles is the Yagni principle. And Yagni means you aren't gonna need it. Simply do not implement something that you don't need. When you need it, just go ahead and implement it. Most of the time when you try to foresee very far tasks, they will be useless and no one will use them. So avoid losing resources for nothing. But here is one very critical tip. A good software design is the one that allows extensions. What does it mean? It means that your code is good or your design is good enough if you would like to add more components, more features, it is willing to do that. Sometimes when we would like to add a single task, we discover that a single feature, we discover that we have to get rid of all of the source code to provide the new feature. Design skill is one of the hard skills that you really need a lot of time to master it. So try to think about the future changes, but not to implement them, only to make your code or your design good for them if some of them happen. Again, experience will teach you a lot. This is a nice link to read about Yangi, written by Martin I think Martin. Martin is a British software developer, very active guy, especially in the Java software engineering, as far as I remember. Feel free to read the article. That's all.